Good morning, everyone. This is lecture number 2, and we are dealing with distance and displacement. Do you remember what we had done in the last class? Yes or no? What had we done in the last class? We were dealing with distance and displacement. Yes or no? Do
Yes,
we
sir.
remember it?
Yes, sir.
Okay. We had seen the definitions of distance and displacement. Can anyone tell me what is displacement? What is distance? Fatafat. What is displacement? What is distance? Yes, beta, tell me.
Length of the actual path in a given time.
Length of the actual path traveled is what? Your voice went away, bacha. Length of the actual path is what? Length of the actual path is what? Length of actual path is what? Chintal center.
Length of the actual path followed by body is
Is
known
what?
as displacement.
Is
Distance.
known as displacement.
Distance, sir.
Please don't mistake. Please don't make this mistake, beta. After so much of time. Yes. And what about displacement?
The shortest distance between
Okay, that is what I said. Shortest distance.
initial points to final point.
Okay. Chalo then. I hope everyone is ready. This is the first question that is coming on your screens. Tell me, in the question it has asked what is the displacement. When they are asking displacement, they are talking about the magnitude of displacement. But here, first of all, tell me how much is the distance traveled. First, tell me how much is the distance traveled. A particle, it's not a particle, it's a man. A man goes 10 meters north, 20 meters east. What is the distance and what is the displacement? Who is going to tell me this? Am I audible and visible to all of you, beta? Okay, your mic has a problem. Not a problem, beta. It's okay. Are you trying the question?
Yes, sir.
Okay, try it. Tell me the answer. Just turn. Yes, beta, I can't hear you. Just see whether your mic is off or on. Your sound is not coming. Anyway, forget about the mic. Yeah, go and solve the question. Forget about the mic. You can hear me, na? Forget about the mic. Solve the question. And when you are done, please raise your hands. Don't worry about the mic. We can't indulge ourselves into all these activities and not solve the question. Yes, solve the question first. Mic can be taken care of afterwards. Okay. A man goes 20 meters, 10 meters north, Then it goes 20 meters east. What is the distance and what is the displacement? Yes, anyone? How will you find out the distance traveled? How will you find out the distance? Yes, tell me. If I trace the path of this man, you must understand that this is north, this is east, this is south, and this is west. South and west are not required, so I have not drawn them here. The man moves like this along north. Let us say this is point O to A, and he moves 10 meters. Then he goes towards east to point B, and he moves 20 meters. Can you tell me how much distance he has traveled? Yes. Have you all done this? Yes or no? So what is the distance traveled? I think to find out the distance traveled, what you got to do is just...
Sir, your voice is not audible.
Well, check your speakers, beta. It's audible on the other side, so there is something wrong with your speaker. You can hear me now?
Sir, your voice is not audible, sir.
Beta, please go and check your speaker. I can't help you from here. Please check your speaker. Check your speaker. Everyone, check your speaker. My voice is coming from this end. Something is wrong with your system over there. Check your speaker. So the distance traveled is 10 plus 20. So the distance traveled would be 30 meters. Yes or no? We understand this. What about the displacement? If someone asks me what is the displacement, how would I get the displacement? How will I get the displacement? To get the displacement, I will have to join the initial position with the final position. Yes or no? So this OB vector is my displacement. I hope everyone understands this. This OB vector is my displacement. The green stuff, OB vector is my displacement. They have not asked the they have not asked the direction, but let me talk about both of the things. What is the magnitude of this? What is the direction of this? To find the magnitude of this, we have to find the length of the line OB. How will you get the length of the line OB? This is a right angle triangle, yes or no? So OB is your hypotenuse. This is your hypotenuse H. This is your perpendicular P, and this is your base B. So your hypotenuse becomes root over 10 square base square plus 20 square perpendicular square. Yes or no? So from there you will get root of 500. You can write root of 500 as 10 times root 5. Do we understand this? 10 times root 5. That is the magnitude of displacement that was asked in the question. Now, to find out the direction is from O to B. Direction is from O to B. You can find out this angle theta. You can find out this angle theta. Theta How will you get this angle theta? You can find out tan theta. Tan theta is always perpendicular divided by base. Yes or no? You can see this is the perpendicular, this is the base, 20 divided by 10. That becomes your tan theta. That becomes your angle. Your tan theta ka value is 2. That is the angle that it makes with the north direction. Do we all understand this? Yes or no? The other class, am I audible to you?
Yes, sir.
Have we understood the problem, beta?
Yes, sir.
Everyone? Can I give you a problem now? Everyone has noted this down?
No, sir.
Okay, I will give you a minute to note it down. Please note it down fast so that I can give you the next problem. Remember, problems are very simple. You just have to do them in the correct way. You will understand this? Let me know when you are done so that I can move on to the next problem.
Done, sir.
Okay, then I'm moving on to the next problem. I've sent you a practice sheet for DPP. Did you get it? Problem sheet?
No, sir.
Okay, not a problem. This is a problem from the same sheet, so you don't have to write the problem. It is question number 1 from your DPP practice sheet. Question number 1. You don't have to write the entire question. Just look at the question, solve it, and tell me the answer. A body moves 6 meters north, 8 meters east, and 10 meters vertically upwards. What is the resultant displacement from the initial position? What is the displacement from the initial position? Before solving this question, bacha, can you tell me if you can speak by talking? If you cannot speak, I mean, the mic is not working, by your fingers. What type of motion is this? Is this motion in 1 dimension? Is this motion in 2 dimension? Or is this motion in 3 dimensions? This particular question we are talking about. Is it 1D? Is it 2D? Or is it 3D motion? Yes, bacha. Is it 1D? Is it 2D? Or is it 3D motion? Is it 1D, 2D, or 3D? Tell me, bacha. One D, 2D, or 3D? I'm waiting for your answer, beta. Is it 1D, 2D, or is it 3D? Is it 1D? Is it 2D? Is it 3D? No one knows the answer? 1D, 2D, or 3D? One D motion is motion on a straight line, keeps on moving in the same straight line. 2D motion is motion on a plane, he moves on a plane. 3D motion is motion when he moves in space. He moves in all the 3 dimensions. He moves along x-axis, he moves along y-axis, he also moves along z-axis. Again, ask you the question, is it motion in 1D, 2D or 3D? This is motion in 3D. He has moved north, one axis. He has moved east, second axis. And he has moved up and down, third axis. So this is a question of
3D.
motion in 3 dimensions. Do you understand this? Now, can you tell me the answer? To solve
3D,
any
sir.
question, you may
3D.
draw a diagram. This is the diagram. Yes, anyone has a diagram? Anyone has an answer? You know that we have a unit vector I along x-axis, yes or no? J along y-axis and K along z-axis. Now, if you can see, if you try to understand the motion of this body, how he is moving, let me try to show you. First, he moves along north. Let me write north, south, east, west. This will be north, yes or no? This will be north, yes or no? If this is north, my dear friends, then where is south? This is south. I am probably in the north, you are probably in the south of the country that we are talking. This is, my gentlemen, east, yes or no? Then this is west. What about up and down? Where would be up and down coming?
Up.
This would be coming as up, yes or no?
Sir,
Up.
option A.
Option A is correct. Well done. This will be coming as down. Oops. This would be coming as down. Now, if I look at it, how is it moving? He moves from O to A. He moves 6 meters north. Then he goes. Let us write it like this so that we understand it. From A to B, he moves 8 meters towards east. Then he moves up. I cannot show you up, so I will show it along the z-axis. And he moves 10 meters like this along the z-axis. He's not moving like this. He's moving upwards. Do we understand this? This is the only way I can show it. Now, if I write the displacement, my dear friends, the displacement delta r vector will have 3 components. The component along x, the component along y-axis is 6j. Do we understand this?
Yes, sir.
The component along x-axis, the component along x-axis is 8, so 8i. This is the green one. This is the pink one. And the component along z-axis is 10 plus 10k. This is the answer in vector form. Do we understand this, my dear friends? I have to find out the magnitude of this displacement. How do I find the magnitude of this displacement? If it had 2 components, x and y, it was under root of x square plus y square. If it has 3 components, then it will be under root of x square plus y square plus z square. We understand this? So this will be 6 square plus 8 square plus 10 square ka root. So the answer will be 10 root 2. That would be my magnitude of displacement. We move 6 meters along north, which is y-axis, 8 meters along east, which is your x-axis, then 10 meters up, which is your z-axis, x square plus y square plus z square. That gives me the answer. Do we understand this? Everyone has done this, yes or no? When I give you the next one and you can tell me the answer,
Yes, sir.
fatafat. Looking at the question, can you give me the answer? And this is the question that has come many times in your exam. Again, you don't have to note down the question. You just have to note down the number of the question because this is already there in the sheet that I have given you. This is question number, I think, 3 from the sheet that I have given you. And I await your answers for this one. Question number 3. A boy stops after traveling 3 kilometers towards east, then goes 4 kilometers towards north along a plain road. What type of motion is this? Motion in 1D or motion in 2D or motion in 3D? This is motion in 2D. He moves in one direction, then he moves in the other direction. What is the resultant displacement of the boy? 7, 4, 5, 15. Option 1, option 2, option 3, option 4. And the answer is option 3. 3 square plus 4 square ka root. Do you understand this? Everyone understand this? Yes or no? Under root of x square plus y square. Do we understand this? Yes or no? No, yes. Shall I draw the diagram or you understand this? Not getting any audio, I'm not getting any video. I hope everything is okay on the other side. Do we understand this, bacha?
Yes, sir.
Okay, sir. Can I give you the next question, sir? Next question, sir.
Yes, sir.
The next question, sir. Again, don't worry about noting it down because it is already there. And I hope that you will get it sooner rather than later. This is again question number 4 from the sheet that I have already sent you. And here it comes on your screen. Read the question and tell me the answer. If the displacement of a particle is 0, what can we say about the distance covered? It must be 0. It cannot be 0. It is negative. It may or may not be 0. Option number 1, 2, 3, 4. Displacement of a particle is 0. What can we say about the distance traveled? Don't have to write the question, just tell me the answer. Think about the answer. The sheet is already on your way. You must be getting it today. 1, 2, 3, 4, and the answer is displacement is 0. What can you say about the distance? Displacement is 0. That means either it has not moved or it has moved and come back to the same position. Yes or no? So
D, sir.
the option is, if the displacement
D.
of the particle is 0, then what we can say about the distance traveled? And the answer is, my dear friends, D. it may or may not be 0, because displacement can be 0 if the particle does not move. The particle does not move, then distance is 0. If the particle moves and comes back to the same position, then the distance is not 0. Do we understand this? That is how questions are framed, my dear friends. Do we understand them now? Why
Yes,
it
sir.
may or may not be 0. Please remember these small tricks that they are going to do in the examination hall. Can I pass on the next question, please?
Yes, sir.
Okay, here comes the next question right on your screens. And again, this question is from the sheet that I've already sent you. You don't need to write down the question. No time for writing down the question. Comes the next one in line. The location of a particle has changed. What can we say about the displacement and the distance traveled by the particle? Option A, both cannot be 0. One of the two may be 0. Both must be 0. If one is positive, the other is negative, and vice versa. Which is the correct option, my dear friends?
A, sir.
A, sir, is the right option, sir. Option A, both cannot be 0. The position has changed. If the position has changed, displacement cannot be 0. And if the position has changed, my dear friends, distance is definitely not 0. Do we understand this? Yes or no? No, yes. Do we understand this?
Yes,
Oh.
sir.
Okay, well done. Now one more question, and then we will say bye-bye to this concept of distance and displacement. And I hope that one of these questions would come in your exam if it ever comes. Here comes the next one. This is not a question from the sheet. So here it comes on your screens. Now, a body moves 1/4 of a circular arc of a circle of radius r. What is the magnitude of distance travel? Distance travel always has magnitude. And the magnitude of displacement. So to tell me what is the magnitude of distance and what is the magnitude of displacement, and your, my dear friends, your time starts now. And I hope and I pray and I wish that you should be able to solve this question, my dear friends. Do you also think the same? You'll be able to solve this, yes or no? No, yes. Option 1, and I have the answer straight away. Well done, my dear friends. That is the correct answer. Option A. I hope we are not guessing. Guessing is not a good thing. No. Okay, I trust you that you have done this. Don't worry. I trust you. I'll give you 1 minute to the other students so that I should be fair. Remember, I am the fairest of them all. There was a Snow White story. Mirror, mirror on the wall, who is the fairest of them all? I am the fairest of them all. Not in terms of the color of the skin, but in terms of being partial or impartial. Who is the fairest? I am the fairest. Martin Luther King, pioneers of what or color and all those things. He once said, "I dream of a day when people are judged not by the color of their skin, but by the content of their character. So we should not judge people by the color of their skin or the language that they speak or the place that they belong from or the faith that they follow. They must be judged by the content of their character. And your content must be fairest. And anyone with the answer? I have one answer. What about the others? To solve any question, it's always good to draw a diagram, and the diagram comes big on your big screen. It's moving along the circle. As you can see, the starting point is definitely A. I hope you all understand this. A is your starting point, or I can call it the initial position. Yes or no? What has happened? My screen has gone bonkers. Well, things happen in life, and we must be prepared for the eventuality. And I'm always prepared for the eventuality, so don't worry about this. Screen is going to come right away. Nothing can stop us in solving this problem. So the screen is right there on your screens now. The camera is also gone away. Something wrong happened with the entire Zoom setup. Anyways, your A is the initial position, and this point B is definitely our final position. Right? We have to find out the distance traveled. That is the first part of the question. I have to find out the distance. And if we remember correctly, and we should remember correctly, distance is the length of the path. Now I have to look at the path, and the path he is going to follow is in the form of quarter of a circle. So to find out the distance, I have to find out the length of this path. Yes or no? The length of this path will be the distance. Do we all understand this? Length of this path is quarter of a circle, circumference of the quarter of the circle. Full circle is 2 pi r. So quarter of a circle is 2 pi r by 4. So my answer will be pi r by 2. We understand this? As soon as you get the first answer, you don't have to look for the other answers, because it's evident from the options that only option that can be correct is A. But there can be a question where pi r by 2 may come more than once. So it's better and it's always wise to solve the entire question correctly. That would be the way to go about it. So now we will write the displacement delta r vector. And when I write displacement, I will write it completely. I'll have to draw a vector joining initial point A to final point B. Yes or no? That vector here is AB vector. Now this AB vector has two components. One is the magnitude, the other one is the direction. To find out the magnitude, I have to find out the length of this straight line. It is very easy because this is r, and this is 90 degrees. So r square plus r square ka root, hypotenuse Pythagoras theorem, it will be root 2r. Do we understand this? Yes or no? So my magnitude of displacement comes as root 2r. As soon as you get it, you have solved the question. But just to tell you about the direction, to find out the direction, my dear friends, you have to find out the value of some angle. Let me call this angle as theta. I will find out the value of this angle theta. Anyone can see this theta? Yes or no? To find out the value of this angle, I will find out the value of tan theta. Tan theta will be perpendicular divided by base. So tan theta will be r divided by r. Tan theta will be equal to 1, or theta will be equal to 45 degrees. If someone asks you the angle, you also know the angle. So you know both the things about displacement, you know the magnitude, and you know the direction. Do we understand this, everyone in the class? Let us stay happy always. I will give you 1 minute for everyone who has not been able to solve this question to note it down, and then we will move on to more greener pastures, more greenery. More greenery means we will go ahead and understand more terms. Are we ready for the magic? Then let's begin. And the next heading that we are going to do, the next term that we are going to study, the next thing that is going to come, what is the name of that next thing? That thing is known as your friendly neighborhood, speed. Spider-Man is the friendly neighborhood. In our case, it is speed. Now, as soon as you hear the word speed, can you tell me what do you mean by this term speed? And as always, I will write everything point-wise so you can remember them point-wise. Don't have to remember long paragraphs. What is speed? No one can speak because don't think mics are working anyway. So I will write the definition of speed since mic don't work. So what is speed? Rate of distance covered with time. If a body is covering distance, obviously time is also passing. The rate at which the body covers distance with time, the rate at which the body covers distance with time is known as speed. Do we understand this? Yes or no? Don't be worried about that system, yeah. Go and study. Forget about the system. Study. Rate at which distance is covered with time is known as speed. Do we understand this? Then, what type of quantity is speed? Speed is a scalar quantity. That means it only has magnitude. It only has magnitude. Can speed of a body be negative? Have you ever asked anyone, what is your speed? They said minus 30 meters per second. Can speed of a particle or a body be negative? This is a yes, this is a no. Can speed of a body be negative? Positive? I mean, yes. Yes, sir, it can be negative. No, sir, it cannot be negative. And the answer is speed is always positive. Why is it always positive? Because distance traveled is always positive. And is the rate at which you are traveling that distance. Therefore, it is always going to be positive. The SI unit is meter per second. I hope all of you know this. And the dimension is LT minus 1. So whatever type of speed we deal with, whether it is RMS speed, uniform speed, this speed, that speed, all speeds will have the same unit, SI unit, and the same dimension. I hope you understand this, yes or no? Keep on writing. As soon as we deal with speeds, we must move ahead and understand the different types of speed that we might encounter in our quest for excellence. Different types of speed. You must have heard about these. This much you have written. The definition of speed. What are the different types of speed then? The first type of speed that we are going to deal with is our friendly neighborhood. Uniform speed. Uniform speed. I hope you have heard this term, uniform speed. Yes or no? Now, instead of using the term uniform, we can also use another term which is constant, or a very simple term in English, same. Constant or same. Now, as soon as I have used these words, the meaning of this uniform speed becomes very clear. Yes or no? What will you mean by a uniform speed? Uniform speed means The speed of the body is uniform. Speed of the body is constant. Speed of the body remains same. You can say it this way, or you can say it in another way, which probably you would have heard in your 9th standard. It travels equal distances in equal intervals of time. Have you heard this? A body covering equal distances in equal intervals of time. You can call, no, we call that speed as uniform speed, or you can say speed remains same or constant with time. And therefore, you can also use the word same or constant. Do we understand this? Uniform speed, constant speed. We have heard this term many a times in our lives. We have heard this term many a times in our life, and that should not come as a surprise to all of us. Yes or no? No, yes. And then comes this gentleman who is going to show us what is meant by this uniform speed. This is a motorcyclist, and as you can see, in equal intervals of time, 1 second, 1 second, 1 second, 1 second, 1 second, 1 second. This is 1 second, not 1 meter per second. He is moving the same distance, 5 meters, 5 meters, 5 meters, 5 meters, 5 meters. Therefore, his speed is constant, same, uniform, 5 meters per second, 5 meters per second, 5 meters. This is what we understand. Don't have to draw this motorcyclist. He is just here to help us out. He is a delivery boy, and he has delivered the message, I think, correctly. That this is what you mean by uniform speed. Yes or no? No, yes. Now, as soon as we have understood that the first type of speed is uniform speed, then automatically the second type of speed comes into the picture. And what is the second type of speed that we will encounter? That will be known as non-uniform speed. You can also call this as variable, something that changes with time. You can call that speed as non-uniform or variable. So, how would you understand this? He will cover unequal distances because we want to keep the intervals of time same. He will cover unequal distances in equal intervals of time. Do we understand this? Yes or no? No, yes. Or you can understand them in a simple English. Speed remains. Speed is variable, or it changes with time. This is again a simple way of understanding non-uniform or variable speed. Do we understand this? Yes or no? No, yes. And then our delivery boy has to come back again to deliver this message, and the message is very clear. As you can see now, the time interval is same, 1 second, 1 second, 1 second, 1 second, 1 second. But the distance is moving in each every second. 5, 8, 10, 4, 6, 7. And therefore his speed is changing 5 meters per second, 8 meters per second, 10 meters per second, 4 meters per second, 6 meters. Non-uniform or variable speed. Do we understand this? You don't have to draw this cyclist because he is just here to do his job, and then he'll go away. So he has gone away right now. Disappeared. He delivered his message, and it disappeared. And I request you to give him good readings so that he can come back again. Anyways, we have to move ahead in life. What is the third type of speed that we shall encounter? Third type of speed, and I hope you would have heard this name as well, is our friendly neighborhood part 3. The last movie of Spider-Man, all the Spider-Mans came together. So right now, all the Spider-Mans from all the Spider-Verses and all the multiverses are coming together. Average speed is the next. Type of speed. Now, how I'm going to denote this, and that is interesting. I will denote this by this dabba. You can see this box, this dabba. When I say dabba, this is the dabba I'm talking about. This dabba denotes average. This box denotes average, and most of the books will use V for speed. They will also use V for velocity, and that will create a confusion because then we start to think of speed as velocity and velocity as speed, which is not correct. So in order to avoid that confusion, I will not use V for speed. I shall use S for speed. And remember, I have not used S for displacement, so that does not create any confusion with speed displacement. I have used delta R for displacement. So my concept remains same. Remains simple. Speed should be starting with S. So I should denote it by S. Why should I use V? Because V is going to create confusion a lot. So dabba means average and S means speed. Dabba S means average speed. Now what do you mean by average speed, my dear friends? Can't, I mean, you can speak, but your voice will not come to me because of problem with the mic. So I'll let you know what do you mean by average speed. It is the total distance traveled. Now, as soon as I say total distance traveled divided by total time, that gives us the average speed. I think you come every day from your home to the class, school, and at sometimes you are moving very fast. You might encounter traffic signals or traffic, and your speed becomes low. At red light, your speed becomes 0. So you will have different speeds at different points in time. But when I ask you, how much is the distance of your home from your school? You say 5 kilometers. And how much time you have taken to come? You say 1 hour. You divide 5 kilometers, that is the total distance, by 1 hour. That gives you your average speed. Do we understand this? 5 kilometers total distance, 1 hour total time. That is your average speed. Total distance divided by total time. Do we understand this? Yes or no? Now remember, this average or this dabba is always calculated over what has happened. Oh, funny things happen in life. We must not get distracted by those funny things. Why is this happening? I don't understand. Anyways, I think we are back online. Yes? Okay. Things happen. Why is this crashing? I don't know. Okay. So what I was saying was total distance divided by total time is your average speed. And it is always calculated over an interval of time. You need 2 points of time from home to school in that interval, from here to there in that interval, from 5 seconds to 10 seconds in that interval. Whatever you calculate in an interval, my dear friend, from here to there, from this time to that time, total distance divided by total time, that becomes your average speed. Do we understand this? Yes or no? No, yes. Now I shall write the formula, and I will never use V for speed. I will use S. S with a dabba. Total distance L divided by total time. Instead of writing it as L, I can write it as delta L divided by delta T. Doesn't matter. It's just a matter of using different symbols. This is my average speed. My average speed is total distance divided by total time. Do we understand this? Average speed, total distance divided by total time. This is your formula number 1. Now I can write this formula in different ways. For example, I can write L as average speed multiplied by T. So your distance becomes average speed multiplied by time. Do we understand this? Remember, this is not a new formula. This is the same formula, but written in a different way. Do we understand this? So you can remember this as formula number 2. But remember, this is not a different formula. This is the same formula, just written
sir.
in a different way. Yeah, the voices come. You see, you keep on trying, and one day you will succeed. Don't give up trying. Okay.
Okay,
So this is the same formula written in a different way. I can write it in a different way. I can find out time from speed and distance, and there's no rocket science behind this. L divided by average speed. Do we understand this?
Yes, sir.
This is the same formula, but now written in the form of time. If you remember any one of these, you should be. Oops, this 3 is not coming good. 3. Now it's better. And always keep on trying, and one day you shall succeed. That is average speed. It is always calculated over an interval of time. Do we understand this?
Yes, sir.
Then there must be something which we can calculate at any particular time. What is that thing that you can calculate at any particular time? That thing is known as the fourth thing, and that fourth thing is known as instantaneous speed. That fourth thing is known as instantaneous speed. And you must understand that physics is very simple. The meaning of the term is hidden in the term itself. Books will use V for instantaneous speed. I will use S for instantaneous speed. What do you mean by instantaneous speed? It's written in the definition itself. It is the speed at any instant or any point in time. This is the speed. How do you find your instantaneous speed? Suppose you are on a bike or in a car. This bike and a car has something known as a speedometer. Yes or no?
Yes, sir.
Instantaneous speed should always remind you of that speedometer. Now, depending on how fast or how slow you are moving, that speedometer keeps on varying. Sometimes it might show 40 km per hour. After 1 second, it might show you 50 km per hour, depending on whether you have speed up or you have slowed down. This instantaneous speed is given by your speedometer. Do we understand this?
Yes, sir.
This is the speed at any given instant of time. How do I find it? It is dl by dt. dl means small distance, dt means small time. Do we understand this? This is maths.
Yes, sir.
Now, as soon as you write it as dl by dt, my dear friends, you can also write it now like this. It is the rate of distance traveled It is the rate of distance traveled with time. Yes or no? Because dl by dt or d by dt means rate of change of distance, rate of change of something with time. Yes or no?
Yes, sir.
Now, as soon as you hear this term rate of change of distance, now that should remind you of the first definition that we did. And the first definition that we did was the definition of speed. And in that definition of speed, we also said the same thing. It is the rate of distance traveled with time. Yes or no? That means when someone is using this term speed beta, is actually referring to your instantaneous speed. For example, if you are on a bike and I ask you, yes, bacha, what is your speed? You will look at the speedometer and tell, sir, my speed is 40 km per hour. I have not asked you your instantaneous speed. I've just said speed. And as soon as you hear the word speed, you will always tell me what is your speed at that moment. So whenever we use the term speed, we are basically talking about which speed? Whenever we are using the term speed, which speed are we talking about? We are talking about instantaneous speed. Because if I want to ask your average speed, I will ask my question in this way. Beta, you have come from home to school. What was your average speed? So you will say, sir, I have traveled the distance of 5 kilometers. I have taken 1 hour. My average speed is 5 divided by 1, 5 kilometer per hour. But then I ask you, okay, beta, what was your speed at 8:20 a.m.? You will say, sir, at 8:20 a.m. my speed was 50 km per hour. That 50 km per hour becomes your instantaneous speed because it was the speed at 8:20. Do we understand this? Average speed is always over a interval of time. Instantaneous speed is at one time. Do we understand this?
Yes, sir.
That is where I will end today's class. I hope you have noted down everything that we have done. The recording will be available, so not a problem. You can always watch it. I will end this class here. What we have done in today's class, we have taken a few steps. We have done some problems in distance and displacement, and we have moved on to speed. In the next class, we'll solve a few questions on speed, and then we will move on to velocities and the other terms that are going to come. I'll end this class here. You have other class to go. So take care. May God bless you all. And may God keep you healthy. Not healthy. Healthy and happy. Mix the two and it becomes healthy. Okay. Take care. God bless you all.